Hello class, this is our last example for our derivative of hyperbolic functions. So this is our example number 5, our last example for this topic. So we're given here, differentiate a function of z or g sub z equal to z plus 1 divided by hyperbolic tangent of z. Alright, so for our solution, let us copy the given function. Function of z equal to z plus 1 divided by hyperbolic tangent of z. Okay, and we are asked to differentiate or find the derivative of this given function. So derivative is, you just take the derivative on both sides, or simply we have g prime of z equal to, so the derivative of the given function, which is z plus 1 divided by hyperbolic tangent of z. So derivative of this function with respect to z. Okay, so how will we solve this problem, class? So we are going to use the formula, we call it quotient rule. So we have the formula, the quotient rule, derivative of u divided by v with respect to x. So the formula is v times the derivative of u with respect to x minus u times the derivative of v with respect to x divided by v squared. Okay, so if our function is a function of x, this is our formula, but now we are given another function which is a function of z. So therefore the formula would be the derivative of u divided by v with respect to z. So this will be the v times the derivative of u with respect to z minus u times the derivative of v with respect to z divided by v squared. Okay, so they're just the same. It's a matter of finding what is our u, what is our v. So in this case, this is our u, alright, and this is our v. So u is equal to z plus 1. So the derivative of u with respect to z is equal to, so derivative of z, so use the sum rule here, derivative of z with respect to z is equal to 1. Derivative of 1 with respect to z is equal to 0. So therefore we have only equal to 1. Alright, then we have v. So what is our v? Our v is hyperbolic tangent of z. So what is the derivative of v with respect to z? So now hyperbolic tangent. So what is the formula, class? So for tangent hyperbolic, so this is equivalent to hyperbolic secant squared of z. Okay, so if the function is a function of x, so this would be x, but now since the function is a function of z, so we have z also. Alright, so this is the derivative of the hyperbolic tangent of z, which is the square of the hyperbolic secant of z. Okay, now substituting using this result and substitute this to our derivative. So we have g prime of z equal to, so v. Okay, our formula is v times derivative of u with respect to z. So our v is equal to hyperbolic tangent of z, then multiplied by derivative of u with respect to z, which is equal to 1, so times 1, then minus u, our u is z plus 1. Okay, so this is our u, z plus 1, times the derivative of v with respect to z, which is equal to hyperbolic, or the square of the hyperbolic secant of z. Alright, so times hyperbolic secant squared of z, and divided by v squared. Our v is this one, so we have tangent or hyperbolic tangent of z. Okay, and then this is squared. All right, okay, so to continue, g prime of z is equal to, so hyperbolic tangent of z times 1 is just hyperbolic tangent of z. Alright, then minus z plus 1 multiplied by hyperbolic secant squared of z, then divided by, so the denominator can also be written as hyperbolic tangent squared of z. Okay, so this is our final answer. Alright class, I hope you have understood our example number 5. Okay, so thank you very much. In our next session, we are going to focus on the examples on the derivative of inverse hyperbolic functions, so the inverse. Alright, so thank you very much. Have a nice day. Stay safe and healthy always. God bless. Bye.